Hi everyone, today I'm going to be talking about the counting sort algorithm. In this algorithm, there's a technique which is based on keys that occur between a specific range. How does the algorithm work? It works by iterating through each of the items in the array, which is the input, and counts the number of times each of those items occurs. So for instance, we have this array, and we have around, I think, 9 numbers, and the range we know is between 0 and 10, and we have whole numbers. And as you can see, the array is all jumbled up and needs to be sorted. So we count the array as our input, and because we know the range is from 0 to 10, we set up our count array, which ranges from 0 to 10, and we all set them all to 0, but we have them going from 0 to 10, and we'll see where our input array fits in with our counts. So the first one, which is 4, there's one of it, and we put it in the fours count, and we count that as 1 because it's one occurrence of 4. Next, we have 8, and that goes in the 8th place, where it's counted as 1. Now we have another 4, and that increases 4s from 1 to 2, because there's 2 4s now. Next, we have a 2. So instead of 0, we have now 1, 2. Now we have a 9, which similarly takes it from 0 to 1 in the 9's place. We have another 9, which makes it 2 9s. We have a 6. We have another 2, so now there's 2 2s. And finally, we have a 9, which makes it 3 9s. And as you can see, these are the counts we have. So what do we do next? Using these counts, we now compute the item's index in our final sorted array, which will be our output. So we have our counts and we have our sorted output, and you can see that there are 9 boxes because we started with 9 elements in the array that was given to us. So there's no 0 and there's no 1. So the first occurrence is a 2, and there's 2 occurrences that there's 2 2s. So we fill those up in the first 2 boxes. Next, we don't have a 3, but we have 2 4s, and those fill up as well. We don't have a 5, but we have a 6. We don't have a 7, we have an 8. And finally, to fill up the last 3 places, we have 3 9s. And this gives us our final sorted array. And as you can see, it is completely sorted according to its value. This type of sorting algorithm is stable. It maintains the relative order of record with equal keys or values in this case. It is not in place, which we saw. It needs its own separate input array and an output array, and this is not even counting the count array. The running time is this, which is the worst case, which is also the same as the best case, as well as the average case. Because of this running time, this algorithm is asymptomatically faster than other comparison-based algorithms, such as merge sort. The disadvantages of sorting algorithm is that it can only be used for integer elements. As you saw, we had whole numbers because those have a frequency or a range. Other things won't. So it can only be used for these types of elements. Another disadvantage is that there's a range that is given to us. From a simple array, we won't be able to figure out what the range is. It needs to be given, it can't be assumed. Like in our current example, the range could have been from 1 to 9 because we didn't have a 0 and we didn't have a 10, but we knew that the range was 0 to 10 because it was given to us. Another disadvantage is that if the range is too big, there's a lot of space that is required, and that is definitely not ideal in computer science, as we've all learned so far. But despite all this, I feel like this is a really cool algorithm, and I'm a big fan of it. So you should definitely check it out. Thank you.